Okay, it's day 3 of Circle Trig. We're doing a little bit of a review, and I asked kids to figure out how long that little green squiggly line would be. So by now, hopefully you got it. Should have had S equals theta r, and S is the thing we don't know. I call it the sarc, as in S is the arc length. This is an arc, and S is the variable for that. So theta is my degrees. Here's a classic mistake. 84 times 18. Why not? Because you can't do that, because 84 has to be changed to radians. It's not one you have memorized, but you can times it by, and then you need degrees on the bottom, and then you got to remember, what's that little conversion again? What over what? Pi over 180. And then this will cancel this, and then from there I'd use a calculator to grind out the rest of it. All right, and what do you get for the arc length then? How about this? I'm going to estimate it. Just think about this for a second. Do you get if this was a radian? Well, this is 18 either way, but if this was a radian, which it's not, if it was a radian, then it'd be 18. Is that a little bigger than a radian? Yeah, so it should be a little bit bigger than 18. Okay, so like 20-ish, something like that. I don't know. I'm not exactly sure. Who's got the exact answer with a calculator? All right, then, Dice of Destiny. I'll find out who to call on. You should all have it ready. Row 3. Person 4. Have it ready next time. Yes. All right. Can anybody verify 26.3? Lots of hands. Is there any competing answers to that? All right, good. And that's probably it. All right, so then we moved into radians. Like, where are they? Like, where the heck is 11 pi over 6? Well, first thought is you start your angles always right here, and then they open up from there. So if I swing it from there, and this could be a 90, of course, that'd be a 180. So let me just tweak something here. The bottom part lined up a little better. So these are right over the top of each other. Being a little too picky, I think, but that's better. Okay, so that'd be 90, also known as, oh, we should memorize these. I hope you have the big ones memorized. 30 degrees, you should say, oh, that's this many radians. You should have it. Who's got it? Pi over 6. Good. Most of you have that one by now. If you haven't got these, write them down and memorize them. You need to have them down, because it's way too slow to just think it through and go, okay, well, I guess I can draw it. And 30, 45, 60, 90, and 180. Those are the ones that are kind of your bulwark. You got to know those. There's other ones in the real world, of course, but these can build most of the other ones. In other words, 120, well, let's double this one. So if you just have 60 memorized, 120, you just double whatever that was. All right, so, and it does make some sense if you think about it. This 90-degree angle that I have pictured right here, that's halfway to this one, which is where pi is. So I'm going to go from the bottom up. That's pi, and this is halfway to pi. Pi over 2. Who's got 60 memorized? Yes? Pi over 3. And last but not least, the 45. That's half of the 90, if that helps, times by 1/2. What'd you get? Pi over 4 is correct. See how I did that, though? Half the 90, you just take half of this. So times it by 1/2, it'd be pi over 4. The only one that kind of gets left out is pi over 5. Don't memorize pi over 5. It's some weird number of degrees you don't need to know. Okay? But otherwise, all of those up to pi over 6 are biggies. All right, now, what if I asked you for 120 degrees? Do you get that that's double this one? And therefore 2 pi over 3s? That make sense? All right. So now, we need to get better at actually solving where I say what is sine of, 3 pi over 2 or that kind of thing. All right, but to make sure you've got some other super important base information. I'm going to go through this example again like I did yesterday, where if I know this side is y, I know this side is x, and the radius is 1, then what was sine of this angle? This is going to keep coming back. Just like those are really important to memorize, you got to memorize this. Sine is opposite of hypotenuse, right? So what's opposite from this angle? That's the important angle. What's the opposite side? Y. Over what's the hypotenuse? 1. So therefore it's y over 1. So therefore it's y. Sine is y. This height here, I know that's weird, but this height here is the sine of this angle. I know that's strange, but it's true. Okay, how about the x? Well, it's probably easy to guess it. Cosine of the angle is x. But how do I get that? If you look at this angle, cosine's adjacent over hypotenuse, x over 1, so it's x. This only works because this is a 1. If that was something else, if it wasn't the unit circle, then this wouldn't just be y, and this wouldn't just be x. It'd be y over the radius, and x over the radius. That little formula comes back later when we aren't using the unit circle. All right, and the last one is tangent. I told you this yesterday. I know I did. Tangent's y over x, and therefore it's, because it's the opposite over the adjacent, and therefore it's sine over cosine. Those you got to have memorized. They're a big deal. Okay. Next thing, as far as stuff you need to just know. From now on, when you make these circles, that's a terrible one because the center's not in the center. I'm going to try to fix that. And, oh yeah, they separated. Good. So then I can grab this guy and move him up a little bit. There we go. Quadrants 1, 2, 3, and 4. Do you get that those are quadrants? Now, if you didn't, maybe I could do them in Roman numerals, and so you could see them as 1, 2, quadrant 3, and quadrant 4. You got those down, right? So many things to know. So if I say, where is 2 pi over 3? You can go, oh, where's 1 pi over 3? Pi over 3 is 1/3 of the way to pi. 1/3 of the way to pi. So 2 pi over 3. That must be over here, so it must be in quadrant 2. That make sense to you? All right, so where's 5 pi over 4? And what quadrant is it in? 5 pi over 4. And what quadrant is it in? Pause for a second while you're working on that. Okay. If you're going to find 5 pi over 4, please tell me that you started by finding where 1 pi over 4 is. So that would have been smart. 1/4 of pi. 1 pi over 4 is 1/4 of the way to pi. So that's this angle opening up. Come on. There. 1/4 of the way to here. That's 1/4 pi. 2/4 makes half, and that makes sense. Half of pi is 90 degrees. 90 degrees is pi over 2. So 1/4, 2/4, 3/4 pi is there. 4/4, 5/4 pi. Raise your hand if you put it down there. Awesome. And then what quadrant is that in? Quadrant 3. Okay. Next, we got to be able to draw those reference triangles. Remember me telling you about this yesterday, how you could draw a right triangle right here? You always take where it touches the circle and then drop a perpendicular, it's called. That's going to make, this is an old geometry thing in case you've forgotten this. It's going to make a right angle with that and therefore make a right triangle. And therefore you should know all the sides. should be able to go, okay, I know that that's a 45-degree angle. I totally get that you're going to, I would encourage you actually to use degrees. Some teachers say, oh no, they have to do everything in radians. I disagree. Because you already know degrees. You know the 45, 45, 90 triangle. Does anybody in here call it the pi over 4, pi over 4, pi over 2 triangle? Of course not. You call it the 45, 45, 90. So I think it's okay to keep those angle measures in your head and write these in degrees. Could I say that those are pi over 4s? Yeah, because they're 45s. But I think in the context of a right triangle, it just makes sense to use what we're used to, 45, 45, 90. Okay, then, did you get this? Does it have to be 1, 1, root 2? All right, but I'm going to stretch your mind a little bit. What if I say we're in the unit circle? Therefore, the radius has to be 1. And it's not 1. How can we make it 1? I wouldn't multiply it by something. What do you think? How would you make this right here equal 1? Yes. You actually could square, but that wouldn't keep the sides proportional. Do you get how when I take 2 and I square it, and I take 5 and I square it, this one goes up a little bit, this one goes up a lot. So squaring it would get rid of the square root, but it wouldn't keep them proportional. So no squaring. What else could you do? Yes. Yes. If you divided everything by the square root of 2, what just happened is that turned into 1, which is what we wanted if it's going to be the unit circle. And then we can go back to that weird definition thing that the y is the sine y. So the y is the height. It's this. Now, I'd rather just keep your life a little simpler. We're not going to use the unit circle even quite yet. We're just going to keep these as what you're used to, 1, 1, root 2. But do you get all I'd have to do to make it the unit circle is divide by root 2? Okay. And you get why you can do that. If I have a triangle, it's 1, 1, root 2. If I want it to be different sides, as long as I do the same thing to everything, I can times them all by 2, for instance, if that would help me. I can do whatever I want as long as I do it to all the parts. All right, last but not least, what I say was the most common mistake in circle trig? Forgetting the what's? The negatives. There are negative numbers here. That's a negative 1. Why? Because you start at the center, and if you go this direction, that's the negative direction. And how about going down? That's a negative direction. As opposed to if the triangle was up here, this side would not be negative. Okay, so there are 2 negatives, that and that. The other thing I mentioned, but is a really big deal, that's never negative. No matter where it is on the circle, that radius, that's not going to be negative. Okay, there's an exception to everything. If it's the line that's heading like here, if I say it's just a straight line going that way, and there is no radius of your circle, or sorry, there is no hypotenuse of a triangle, then that's negative 1 if it's heading directly that direction. It's kind of still the hypotenuse then, but it's not really the hypotenuse because there's no triangle when they're like that. Okay, again, you don't even understand that part yet, so it's okay if I just say your hypotenuse will never be negative. Okay? All right. So now that I've got this triangle all drawn, and it took a while, the statement I made yesterday was that once you get the triangle all drawn and labeled, then the trig part's easy. Like, for instance, right now, would you find sine of 5 pi over 4, cosine of 5 pi over 4, and tangent of 5 pi over 4, just being careful with your negatives. I'll pause for a second. Let me figure those out. Notice you do not have to use this as a unit circle to do that. Make sure you're on the right track here. Sine is opposite of hypotenuse. This is the angle in question. They always use the central angle. Triangles have 3 angles, but we only use that central angle. That's the perspective we're using. So from that angle's perspective, what is the sine? It's the opposite over the hypotenuse. So negative 1 over root 2. Raise your hand if you had that one right. Awesome. And then the cosine will be adjacent over hypotenuse. That's the adjacent side from that angle's perspective. So that's -1 over the hypotenuse, √2. And that's the same. Is that weird? Nope, that's what happens with the 45, 45, 90, because they got two angles that are the same. And lastly is tangent. There's a -1 over -1. That makes +1. Now notice that the sine came out negative here, cosine came out negative here, the tangent came out positive. Why? Because we divided two negatives. Tangent was the only one that was positive in that quadrant. That's the next thing that I need to teach you. Just like we had a list of handy things like here, sine is y, cosine is x, etc. And here, which is all the basic ones, you got to have those memorized. And the quadrants, quadrant 1, 2, 3, and 4, they have to be memorized. You have to know them. There's another thing that you have to know. Actually, you don't have to, but I'm telling you, it's incredibly helpful if you memorize this one. Remember, we just did a triangle in this quadrant, and the only thing that was positive was tangent. If you do that same thing, we'll save us some time. On a triangle that's right here, let's say it's a 45, 45, 90, 1, 1, √2, and this is negative, then what would come out negative there? Sine, cosine, or tangent? Or sorry, I shouldn't say it that way. Which one would come out positive? Sine, cosine, or tangent of this angle? Sine would come out positive because that uses the two positive numbers, right? So sine is positive here. This is where we started, and all of them come out positive. If I draw a triangle here, all the sides are positive, so how on earth could you get a negative? You couldn't. So all of them are positive here. And if you notice the pattern here, we've had all of them positive, only sine's positive, tangent's positive. What do you hypothesize the last one is probably going to have as positive? Cosine. It's the only one we haven't used. And if I draw a triangle, I can show you why. Here's my triangle. 1, 1, √2, but which one's negative? That one's negative. And then for this angle right here, cosine would be using adjacent and hypotenuse, and it would stay positive. All right, so here's the thing to memorize. ASTC. All students take calc. Because after this class, all the students take calc. It works actually pretty well. You'll take calc of some form. IB is just a different flavor of calc. AP is a different flavor of calc. Regular calculus, if you're like, this is too hard, I'm not taking the AP next year, well then, regular calculus is what you take instead. The only exception to that would be if you're a junior right now and you want to get off the, like, I don't probably want to take math in college other than stats, then maybe you should take stats next. That'd be if you're a junior right now and you want to not take calculus in college. But that's pretty rare. For kids that are in this class, pretty much all going to take calc. All students take calc, ASTC. Why is it so powerful? Because what if I say, as I'm drawing my little picture, I can tell you that this particular trig problem comes out negative. Sine of the angle is less than 0. That means that sine of the angle came out negative. Then you know where it has to be. Remember, this is where sine is positive, so therefore, where would sine have been negative? You couldn't be here and you couldn't be here. And therefore, your triangle would have to either be here or there if sine was negative. So like little clues, I'm giving you little logic clues in this next section. And this is one of the harder kinds of questions that's on your next test is we'll give you clues like, okay, sine's negative and tangent's also negative. In fact, I'll say tangent of the angle is -1. Well, and that means tangent's negative, right? We already know it can't be here and it can't be here. If tangent's negative, Where else can't it be? Which quadrant did I just rule out by saying tangent was negative? Well, isn't this where tangent's positive? So therefore it can't be here. Therefore, I must be drawing the triangle here. And then if I said tangent was -1, do you get that means that it would be -1/1? Do you get that means I just gave you the sides of the triangle? Think about that. If tangent's -1, tangent of this angle, TOA, opposite over adjacent, that must be the opposite side. That must be the adjacent side. And the opposite side, -1, does that kind of match up with the way the triangle looks? And the adjacent side, +1, isn't that matching up with like a triangle you know? And then 1, 1, and this must be √2, right? So then the question becomes, what is the angle? Notice that's the only thing I didn't give you. I didn't give you theta. You got to figure out theta. And I've drawn you a picture. I bet you can figure out what the angle is. And I want to warn you, the answer is not 45. Because if the answer was 45, then you're saying that the triangle's up here, because that's where 45 is. The answer is not 45. The answer is a really big angle. I'm going to pause for a second while you figure out, what must theta be? Good question. A kid asked, degrees or radians? I'd like both. Find out the answer in both degrees and radians. Yeah, it's a really big angle. I'll give you a hint, it's 300 and something. Okay, for example. Or in the neighborhood of 300 at least, I'll say that. Okay. So, what angle does it have to be? Let me show you the angle. It's, what would be a nice bright color? I guess red probably work. I got to open up all the way around to there. So that's not 360, but you could say it's 360 minus this angle, because if I had gone all the way here, that'd be 360. 360 minus the angle in question, which is a 45. So basically 360 minus 45. Did you get what was that? 315? Okay. All right, so then 315 is a good angle answer in degrees. Do you remember me saying that you could do these in more than one way? Like, for instance, -45 would have been a good answer. Notice that's going down this way, 45. And last but not least, let's go to radians. 45s are pi over what's? Pi over 4. If you haven't memorized that yet, it's 1/4 of the way to pi. Here's pi, and 45 is like there. It's 1/4 of the way to pi, so it's a pi over 4. So these are all pi over 4s. How many pi over 4s? 1, 2, 3, 4, 5, 6, 7 pi over 4. Or you can think of it this way. 8 pi over 4s would have been there, but it's 1 less than that. So therefore 7 pi over 4. And just to finish it off, it could be a negative in radians, negative pi over 4. Any of those would have been good answers. All right, that was a pretty intense one. Remind your partner, what does the T up here mean? I'm going to pause for a second while you say it. Yes, tangent is positive down there. In quadrant what? In quadrant 3, tangent is positive. Okay. So what if I give you these clues? Cosine's negative, but tangent's positive. Where are you? Cosine's negative, but tangent's positive. I'm going to pause where you find your quadrant. Cosine's negative. Do you get how I can rule out this spot? And then all of them are positive in this place, so cosine can't be negative up there. So we're down to these two spots left, S or T. And if tangent is positive, oh, that narrows it down to, must be that one. Did you use quadrant 3? All right. ASTC. Get used to it. It's really handy. Okay. Next thing I need to teach you for today is kind of related to what we're talking about, but it's definitely different. And we talked about it before on the drone day last semester, and that's about rotational motion. Okay, if something is spinning, like the blade of a drone, is spinning in this direction. It has what's called rotational motion because it's going around and around and around. But if you wanted to like just put a little fleck of, like I put a little dot on one of my blades and then said, how fast is that dot actually going? If I say it's going 2,000 rotations per minute, RPMs, you've heard of those, right? If it's going 2,000 RPMs, then what do I do to get that turned into miles per hour? If it's doing rotations per minute, how do I get that to be miles per hour? This fits into our next test. So you learned it back with the drone day. I know some of you weren't here. I'm going to reteach it right now so that you can have a chance to get it right. But you need to do a practice problem with me. Everybody, on a blank notability doc, start with 2,000 ROT over 1 MIN. Do you get I'm just writing out rotations per minute so that I can see where the units are? Circle trig, there's circles involved here. There's arcs involved. Do you get that the distance that that dot is going is actually just making multiple arcs, full circles? All right, next thing we need to know is how long this is. And let's say that it is an 8-inch long radius of the little blade. Why is that important? Because we need to figure out how far a rotation is. One rotation. Why? Because if I'm going to convert this, I multiply by conversion factors, which are like facts. This is a fact that 1 minute has 60 seconds, but don't use it. You know why? Because this would change my problem and give me rotations per second. That's not what I want. But that's the kind of thing we're going to multiply by, is a fact, like 1 minute is 60 seconds. What is a fact that actually helps us get to miles per hour? What is a fact you can multiply by here that will get you closer to miles per hour? Well, how about we get rid of rotations first? That's the hardest part. If I'm going to do that, I've got to put a rotation on the bottom. And it's fairly easy to tell what a one rotation would be. That little dot then is going to go all the way around one rotation. And how far is that? That's also known as a circumference, right? And hopefully you've memorized the formula for circumference of a circle. Circumference is, who's got it? Pi times the diameter, or 2 pi r, which is 2 radiuses instead of the diameter. To get either of those is a right answer for circumference. If you haven't memorized those, memorize them. They come up on the ACT. The ACT doesn't give you a formula sheet. This would be such an easy question to nail on the ACT. But you got to know circumference formulas to have a chance. All right, so what's a fact about rotations? One rotation is what? One rotation is how far? Well, it's a circumference. And how far is the circumference of this thing? A circumference would be pi times the diameter, or 2 pi r. I might as well use the 2 pi r one because they gave me the radius. So 2 pi times 8, which would be 16 pi. Do you get that this thing's going to go around 16 times 3.14 inches? You following me there? 16 pi inches. That's one rotation. That's how far that blade goes. If you need it as a decimal, go take 16 times 3. About 48 inches or so is how far that little tip of the blade would travel. I know it's not that because it's 3.14, but that's about how far it is. Okay, now why did I do that? I times by that so that the rotations would cancel. Now I have inches per minute. See, because that's what I have left, inches per minute. So then I'm going to multiply by something else. Inches per minute. What should I get rid of, inches or minutes? I don't care, you pick. Okay, let's get rid of minutes. So I'm putting minutes on the top so that they will cancel with the bottom, right? What's the fact about minutes that you know? 1 minute, 60 seconds, that doesn't help. 60 minutes, 1 hour, that would help. And now I've got inches per hour left. I'm getting close. I got the hours that I wanted. What do I want now? Miles. Have you memorized how many inches per mile? Nobody does. But I bet there's one you could do that's really easy that would get inches out of there. Yeah, inches goes on the bottom. And then I'm going to help you. You're going to use your calculator to finish this, but somebody has it memorized. How many feet in a mile? And by the way, just so you know, later this semester, if you don't know that number on a test, you will not get an A on the test. So memorize how many feet are in a mile right now. Who's got it? Raise your hand if you got it. One kid in the room would get an A on that test. Well, then you better memorize it, right? Write it down. 5280, 5,280. I didn't want you to say it just in case you said it wrong and it was sticking all your heads wrong. Okay, so I believe you knew it. 5,280. Use that and use another little conversion with inches, and you should be able to finish this deal. Show your work too. If you skip a bunch of steps at the end, like mine right now, I would not give credit for that. Show me. Well, all the units. The units are a big deal. If you did, is it called physics where they do stoichiometry? Chemistry? Okay. So it's like that. Or dimensional analysis is another name you may have heard it called. This should be an easy place on your test. This is going to be the happy place on your test because there's really not much trig involved. Okay. I'm going to pause while you finish that last few steps. In case you don't know what to do at the end, you multiply all the way across the tops, and then you multiply all the numbers that are on the bottom. And then you divide the top divided by the bottom to get your final answer. Raise your hand if you've got the final answer already. All right, then I'm going to wait just a minute. Okay, so you have, what's this thing about inches? 12 inches, 1 foot. First time we had a number on the bottom. And now my inches can cancel my inches, and my answer's in feet per hour. Close. I just need miles per hour. So I have to multiply by one more conversion factor, so I'll move this stuff down. Last conversion factor to multiply by 5,280 feet. But where should I put it? Top or bottom? Bottom, because I need feet to cancel feet, so the feet need to be down here. 5,280. And then this is 1 mile. That means my answer is in miles per hour. Cool. You multiply all the way across the top, multiply all across the bottom, and you divide them. What did you get, Mr. ML? 95.12 miles per hour. Can anybody verify 95.1? All right, good. If you didn't get that, just multiply all the numbers that are on the top. Multiply all the numbers on the bottom. Divide the two answers. You might, if you try to put it all in one big statement, you're going to screw it up because it's going to do the order of operations wrong. So just get your number for the top, get your number for the bottom, divide them. If you are absolutely positive that that's a wrong answer, please correct us. But there's a lot of kids that verified it, so it's probably right. Okay? All right. So what are we doing for today? I want to actually find that homework file and get you to the same spot as me. Everybody find the file that says, it's today's date on it, of course, and then it's called 12.2. But go to this slide, which in mine is slide 26. It's not last night's homework. This is a new one. There's a new file for today. If you haven't found it on Schoology, find it quickly. Okay, so we are only going to be able to do certain ones because I haven't showed you this thing called quadrantals. I've only showed you the ones where you can make triangles for it. But if you're at 0 degrees, how on earth could you make a triangle out of that? You can't. You can't, it's not like opened up like here where you can make a triangle out of it. You have, it's just 0. How do you do sine of 0? I'll show you that tomorrow. Okay, for right now, we're going to do the ones where you can make triangles. And that's going to be this one, and this one, and this one, and this one. Now some of these, and this one. I don't think we need to do too many of these, so we'll go here. 7 pi over 4, and that's good, but 23 pi over 6. Now that's going to be like, what? Just count up a whole bunch of pi over 6s, and yes, you're going to go all the way around the circle more than once before you finally stop. All right, next page. This is one that I just showed you a second ago. It says some clues, like it says it's in quadrant 3. Do you know where to draw the triangle then? Right away I know, oh, quadrant 3, it's down here. That's what the triangle's got to look like. And then they tell me the cosine of the angle. Didn't they just tell me 2 sides by saying that? They told me the cosine of the angle, they just told me 2 of the sides of this triangle. From 2 of the sides, couldn't I figure out the 3rd side because it's a right triangle? And then couldn't I figure out the sine of this angle? It's like a little puzzle. And this is a typical test question. So we're going to do this one and this one. Find all 3 sides of the triangle, and then these become easy. Like if I said this was a 3, 4, 5 triangle. 3, 4, 5. I'm not saying that's right, but if I did, then what's the sine of it? Oh, opposite over hypotenuse, 3/5. They're really easy once you have the sides down. And they gave you 2 of the sides. They gave you one of the sides is 2, one of the sides is 11. So you just have to put the little pieces of the puzzle together, and it's a no big deal. All right, now let's go back to the beginning, this part, and let's find one of these and do it. Let's just do the first one, number 2. Pi over 4. The first thing I want you to always do is make that and a circle. Just always do it. And then inside it, make your triangle. Because where the triangle is matters a lot because of that negative thing. If you just draw a triangle, you're going to screw up your negatives. All right, so now I'm going to go to where pi over 4 is. It's right there. Now I got that. Do you know where the triangle has to be? Drop a perpendicular. That'll be this little blue line here. And now I got my triangle. And it says it's pi over 4. This is where that memorizing's got to come in. Oh, that's 45 degrees. I know that one. So if it's 45 degrees, then this is 1, 1, square root of 2. Next step. Is there any negatives? Not on this one because we're in quadrant 1. If we'd have been drawing this triangle over here, there'd have been negatives involved, for example. All right. And the last thing is, find the exact value of cosine and sine. Yeah, you don't have to do tangent. So what's the cosine of this? From this angle's perspective, cosine adjacent over hypotenuse, 1 over root 2. And when it says exact value, do you get, I could go round off the decimal for the square root of 2 and find out a decimal answer, but that would be rounded. So leaving it as 1 over square root of 2, that's exact. One warning, on the test, sometimes they rationalize the denominators. What if they don't have the answer of 1 over root 2? It's because they did this, which would be square root of 2 over 2. So don't freak out if they have multiplied to rationalize the denominator. All right, so your final answer on that, the sine of it is 1 over root 2, and the cosine of it is the same because that's how this triangle works. All right, that's all I got for you for today.